Yeah, the homework from last week was probably a lot harder than the other weeks. I have to still get to grading the homework, so I haven't seen like your guys' responses yet. I think someone else might have been grading up though. Um, but let's get started. Um, so welcome to Intro Physics. I think this is class 8 now. We'll be going over like a review of tension or the Atwood machines because I know it was getting a bit complicated last time, so I wanted to kind of go through a review of that because it's really important to understand what Atwood machines are and how they work. And then we'll work on rotational kinematics, which is if you get how to do normal kinematics, rotational kinematics is pretty easy because you're just replacing variables. But this is just a quick review. This is like tension. I know we did this last two classes, but um, you know, the main thing I want to keep on stressing is the fact that sorry, is the fact that this upwards force is equal to tension, and this downwards force is the mass times gravity of this block. And since this block is still, this means that the tension is equal to the mass times gravity because it's still, correct? It's not accelerating. So that means the net force is, do you guys get this part when I say tension is equal to mass times gravity? Does this make sense to you guys? Yes, yes. Yeah, okay. Um, so this is because it's still, right? All right, give me a second. Um, this is because it is still, right? Is there another slide that, no, it doesn't. Okay. But let's say that because we know force, I'm gonna put this up here. Force equals mass times acceleration, correct? This is probably engraved in your guys' brains by now because I've been stressing this a lot, but force equals mass times acceleration. This is Newton's second law, right? And basically this force is equal, like we want to keep the mass times acceleration this side the same, right? This is gonna stay the same, but this force can change because there's different things that put a different force, right? Let's say this block is accelerating upwards by 2 meters per second, correct? 2 meters per second. Now this block is no longer still, right? So the tension does not equal mass times gravity, correct? Because this is only true when it's not accelerating. So what happens here is we can put the thing that confuses me isn't weight and mass the same thing. No, on Earth, that's the thing. So weight is technically equal to mass times gravity, but force is different than weight, right? On Earth, technically, like weight and force, like when you're talking about weight and force, it's the same thing, but like mass itself isn't weight because mass is some how much something, if you think about it, weight can change on different planets, right? If you go to Pluto, your weight is going to be much less because the gravitational force on Pluto, or sorry, not, I meant the moon. On Earth's moon, the gravitational force of the Earth's moon is around 1.6, 1.7 almost. I don't want to see any jokes in the chat, but it's around 1.67, correct? It's 1.67 meters per second squared, pulling it down on here, which makes the weight of someone on the moon much lighter than someone on Earth. But the mass is how much the person holds, right? So imagine Bob. Bob is on Earth, right? And let's say he weighs Um, kind of like how do I explain this? Like, yeah, almost, yeah. But like to clear up what weight, like like mass doesn't change wherever you go, but weight does. Does that make sense? If Bob weighs 50 kilograms on Earth, he would weigh what? A lot less on the moon, around 10, sorry, around 10 kilograms or something like that, right? Because his weight changes, but the amount of stuff in his body is still there, right? Does that make sense? His mass would be that's a good question. Like, so mass is what makes up mass isn't what makes up the substance. Mass is like mass is everything inside of him. It's like it's not like like it's everything in total. Like if you take this box and there's a lot of stuff in this box, the amount of stuff in the box won't change wherever you go. But how heavy it is will change whether you're on Earth or the moon, right? Does that make sense? They just use like I don't know why they do that, but whenever someone says like 60 kilograms, that's how much like they weigh, which is like I don't know why they do that because it's confusing, but like it's not the same as the mass, like on a different planet. Matter, an object, and a measure of its resistance to acceleration. Um, yeah, I mean, you could put it like that. I just feel like that would be a bit complicated to like understand. I mean, it's not bad if you search it online. I wouldn't like if you guys think you guys would understand it by searching it better online, it's not a bad idea. But sorry, back to what I was saying. If ooh, let's delete Bob. Let's delete Bob and the moon. Bye, Bob. Okay. So back to what I was saying, right? I also can delete this box actually. Okay. Back to what I was saying, right? We have this, let's say this is an elevator, right? An elevator is accelerating at 2 meters per second upwards, correct? So now this now this elevator isn't stationary, so the tension does not equal the mass times gravity, right? But the total there it's still facing both forces, right? It's still facing tension upwards and gravity downwards. And we have to still add those forces up to equal the mass times acceleration, right? We're always going to keep this on one side, and the total and forces that this elevator forces faced is tension and mg, correct? It's facing an upward force and a downward force. But to get the total, and we know that we know the acceleration of this elevator is 2 meters per second, so we can just put it like 2m is equal to tension minus mass times gravity. And remember, it's minus mass times gravity because gravity is downwards, so it's going to be negative. The acceleration will be negative. So if we were taking upwards as positive, or sorry, if we're taking downwards as positive, then it would be tension. Sorry, it would be what? Since this is accelerating upwards, this would be -2 because we're now defining downwards as positive and upwards as negative. If we did that, then it would be -2m minus t plus mg because tension is also acting upwards. Does that make sense to you guys? Well, how the symbols kind of work and how I showed this. Yeah. The tension will be different when something's in an accelerating frame versus when it's like still. So if something when something is still, then the tension is equal to the mass times gravity. But if something's moving, then the tension has to be different because it's moving, correct? Does this make sense to you guys? Sure. Yeah. Okay. I think it'll be better if I do it with a different problem. I can skip all that, right? We did this last time. I don't want to have to do you guys want to do this instead? This is another problem. Let's do this one instead, actually. Because we all did the other one. Okay. So can neither one? Yeah, well, thanks, normal. Um, but let's take these two blocks. Can someone tell me what this block is facing currently? Tell me how this block is gonna move. You just have to tell me its movement, right? Yeah, actually let's start with this block. Tell me what this block is facing. This block is facing two things, right? Tell me both. I'm gonna wait for an answer from anyone. I just need two tension and gravity, correct? Yeah, that's it. So it's facing tension upwards, tension upwards, and gravity downwards, correct? Gee, I should choose a different color. This is hard to see. There we go. Tension upwards. You thought it was a spin rectangle? No, it's these two, right? And gravity downwards. Yeah, it's gonna move, but it's not gonna move upwards how you think it would. Because like if you can imagine, if there's no force being put, this can't just automatically go this way, right? If you keep like a box will never move sideways without an external force, right? It'll move up and down because of gravity, but it'll never move sideways. And right now, I this box could be exerting a big enough force to where it could move this larger box. And even though this box has more mass, it could still be moving this way, correct? So back to what I was saying, right? This box is exerting upwards T and downwards G, correct? Now, what is this box? What do you just put a guess on what you guys think the force will be for this box then? Because we know it's moving this way, correct? But what do you guys think it'll be? For the 1.9 kilogram. Yeah. Okay, and one person got it. He sent me a direct message. But Sushiel's correct. It's just going to be tension. So it's just going to be the tension, correct? Because this string, you can imagine this string, it'll just be stretched out. And let's say you stretch, let's just take it off this thing and it's just stretched out, right? Both of these boxes will be facing the same tension, regardless of where it is, because it just gets spread out through this string, right? So if this is facing an upwards tension, then this tension will be pulling it this way, correct? Does that make sense to you guys? Because gravity is not going to be acting on this box because this box is on a table, right? So the only force acting on the box that's relevant is tension of the string that is pulling the object this way. Does that make sense? Could I get a Y or a thumbs up or yeah? Okay. Good, good, good. So whenever you see a problem like this, you want to you want to like you want to first realize that it's a frictionless surface. So then this means that we're not going to face any problems with friction and gravity, right? So we can realize that since it's on a table, gravity does not matter that much, and the only force that matters is the force that's moving it towards the right in our case, right? And since we only have one force, and we know force is equal to ma, right? And right now we only have one force. That means the force is equal to T, right? So it's just T equals ma, correct? Yeah. Does that make sense? I should put a m sub one. Or yeah, I should just do this. So this is gonna be mass. I'm just gonna use variables for right now because I'll input the numbers later on. So this will be mass. So the box on the table will be mass one, and its acceleration will be a1, correct? Wait. Yeah. Actually, no, the acceleration, you don't need the sub because the acceleration will be the same. But and then for this object, we realized it has two forces, T and G, right? So F is equal to both of these forces combined, right? And we already know that we express G as a downward force, which means it's negative, right? So when you add T plus negative G, you just get T minus G. And remember, F equals ma, so we get T minus G is equal to ma, sorry, m sub 2a, because this is the mass of the second block. Does that make sense? Yes. Do you guys get the second one as well? Could I get some yeses or yeah, m is 1.9, right? M is 1.9 and m2 is 1.2. Some yes or ones, or sorry, yes or thumbs up or no's. Yes, yes. So whenever there's multiple forces acting on an object, on the same object, you just want to add them up, right? And I think that's the trickiest part about these types of problems is adding up all the forces that could be acting on us, right? This case, it's T minus G. So then we have our two equations. Can I erase everything on the board and just have our two equations? Is that fine with you guys? You guys have like you guys are good, right? I'm gonna erase everything because we only need these two equations now. I'm gonna highlight that right now. We only need these two equations because we got them, right? T minus m1a and T minus g equals m2a. Just replace F and then F is the addition of these two, correct? Just those on the board. And so now we have two equations, right? Two equations. We can just replace T with this, right? So then we get M1A minus M. Ooh, sorry, I don't want to mess up. I'm gonna make this M2. That's a 2. And what I did there was I just substituted T for M1A because we don't need T. We just does that make sense? Does this step make sense what I did here? Yes. Yeah. Um Next with this, we're trying to solve for the acceleration, right? Our end goal is acceleration. Is that good enough underlined? Yeah, I think it is. That's always important to know. So what we want is so what we want to do is we want all the acceleration on one side, right? We want to move everything else to the other side. So what I'm gonna do here is I'm gonna add m to g, add m sub 2g, and then minus, I'm gonna put that here. So it's correct. We have this, and then we're just gonna minus m2a from each side because we want all the acceleration on one side. Does that make sense? Yes. I'm gonna go slowly because I don't want anyone to be confused. Yes. Any questions so far with what I did? No. Yes. Yeah. That's why last class I think I was going too fast because you guys wanted to play Book It. But today we'll have time probably because we also spent a lot of time last class on like pressure and like electromagnetic fields and like the electromagnetic spectrum, but none of that today. So yeah. So we have this, right? Can I can I erase all the other steps or no? You want me to keep them? Actually, I'll just start working up here. I'm gonna be working up here now because if people are still behind, they can just look at my other steps. I don't have to be right. So if we have M1A minus M2A equals M2G, you can just what you can do here, what you can do here is you can factor out the A from each side to get. Does that make sense to people how I factored that A out? If you guys know the distributive property, that would be very helpful. Yes. Yeah. Yeah. Good. Um, so then once we have that, what we can end up doing is, sorry. Yeah, what we can end up doing is we can just end up doing dividing, I'm running out of space. A minus M1 minus M2, and then just divide this by M1 minus M2. So these two cancel out. So I can just have A alone, right? And then you just divide this side by, let me, I'm gonna erase some stuff because this is very, my drawings. Okay. I'm gonna what is this? What do I do next? What do we have? Sorry, I'm just rewriting the steps I was doing earlier because I had to, it was getting wild. Um, it makes sense up until now, correct? All this makes sense. Yes. Okay. Now I'm gonna divide each side by a. Also, no one's texting to me privately to my iPad, right? I just because um I'm not gonna look there if you guys have any questions. Um, M1 minus M2. And now we're just gonna divide both sides by M1 minus M2. M1 minus M2. So these cancel out, and then I have acceleration is equal to M2G over M1 minus M2, correct? Does that make sense? Does anyone have questions on how I got A equals anything? Oh, wait. Oh, did I make a mistake? I did. Wait, sorry guys. I think I this is why you guys have to go back and check your work. This is what you having your steps out is for, okay? Um so basically we know that acceleration downwards is equal to negative, right? So since this is accelerating downwards, this is accelerating downwards, this A should be negative actually. Oopsie poopsie, guys. That's on me. Do you guys get why I made the how I made the mistake? Does that make sense on why it's negative and not positive? Yeah. Um, it should be negative, not positive. A because acceleration, if this is accelerating downwards, that should be negative. Because remember we defined going downwards as negative because this is G. This remember how it's T minus G is it's minus G because it's downwards, so this acceleration is also downwards, so it's minus. Oopsies. Okay, so what? It shouldn't be that big of a deal. If this is just gonna be negative, then what? Then this is just positive. Oh, so it's just positive. Oh, okay, yeah, yeah. Then it's just positive. Do you guys get what I did there? Or how I fixed it real quick? If you guys have any questions, feel free to ask, by the way. I know you guys are getting this, but don't be afraid to ask how I just switched it around. Makes sense? Yeah. So then once you do that, you just get, and now this is the fun part. We get to plug in our variables, right? We defined M2 as 1. Oh, we should have defined that before, so no, we didn't get confused. 1.2 and M1, correct? Does that make sense? And now we can just input. We're taking G to be what, 10? Let's just take G to be 10 for now. G is equal to 10 meters per second squared over 3.1. 12 over 3.1, or it's around 4. What? A bit less than 4. It's like around 4. It is when you can just change the minus from a plus. Just add a that's what I do a lot actually. I'll just change it from a wait, doesn't the whole process? I mean, luckily for us right now, it didn't matter too much because all we had to do is like we just had to add M2A to each side instead of minus. So like it would just turn out to be like you just flipped it out. So then it'd just be plus here. It would be plus here instead of minus, and then it would just factor out to be a plus instead of a minus. Does that make sense? On how it like over here it didn't affect us too much. Sometimes it does affect you, and that's why you should probably make sure beforehand. That's on me. But that's like it's like a mistake that's common, and you should focus on not making it because it does change the output. Does that make sense, guys? Can I get a thumbs up or a thumbs down or a no or yes? A little. Where do you think you're confused on, Michelle? Is it just the whole process, like how I like? Because it'll take practice to like kind of get that. So basically how I got that is I just based both of my like once you learn how to create your equations, like using them is pretty simple, I would say. Like once I got these two equations, all I did was just substitute t for m1a, and then I could factor out and do the math. If you're stuck on the math, then I would encourage you to like just work through it by yourself. But if you're stuck on this, what I did was since this is only like the main problem that people face is finding out what the force is equal to, right? On the 1.9 kilogram object, the only force that it's facing is tension with the string. So that's just gonna be T is equal to MA. But for this 1.2 kilogram object, it's facing gravity downwards and tension upwards. So since gravity is negative in this case, what you do is you add sorry, keep on doing you add this with tension. And when you do that, you just get T minus mg to sub in for the force, which is equal to ma. I think what happens is once we solve like the whole thing, and once you're going through it with me, it makes sense. But then as soon as you like try to backtrack, you forget like how we got some of the stuff, even though you got it like while I was explaining it, which is very valid. When I learn concepts, that happens to me a lot, where like someone will teach me after. Oh, you mean plus? Remember we changed it to M1 plus M2. Um, but like we just inputted like there's not much to it after I did explain it kind of fast, but there's not much to it after we got M2G because what we just did was we substituted the numbers in, right? We substituted 1.2 for M2, 1.9 for M1. So then when we did that, we just got, and then G is just gravity, which is just 10 meters per second squared. You know, you'll just like, you'll memorize it, right? Not 10 meters or 9.8, whatever you guys take. But um, You could just input that for G, and then the numbers part isn't too. I wouldn't worry too much if you guys don't get the numbers part because you just substitute it, and like that'll come with practice. Do you get like now? Like I don't want. Should we? I'll just walk through it again. But so since M2 is equal to 1.2, you just input 1.2 for M2. Gravity acceleration is 10 over 3.1 because 1.2 plus 1.9 is equal to 3.1. 1.2, 1.9, or 1.2, 1.9. Correct? Does that make sense to you guys? Are we done with Atwoods for the next two classes? No, for a long time. Okay. Do you guys want a 2 minute break before we go on to kinematics? I give you guys until 47 for kinematics. You guys can go do whatever you guys want for 3 minutes. Feel free to talk in chat or whatever. Okay. So back to what I was saying. Like, free body diagrams are always like really helpful because um it's actually like I think when you get to like physics class, they like require you to do a lot of free body diagrams, but basically what they are is like they're just like drawings of the forces on an object, right? So, like, you always have to label what forces each thing is facing, right? So, in this case, this is even facing you could say this is facing more forces technically. I don't know if we covered it, but yeah, we did. We covered the normal force upwards, tension this way, gravity downwards, but these don't really matter because like they cancel out and whatever, and we only need this one, correct? That's basically what a feedback body diagram is. Um, yeah, you won't see more Atwood machines for a while. Sorry, I keep on bringing it up. Okay, I hope you guys remember your four kinematic equations. I forgot to include the distance one. The distance is equal to initial distance plus velocity times time. I forgot to include that one, but is there only three? Yeah, I only included three by accident. But I hope you remember this. Do you guys want to answer the first question? Quick, quick, quick. 30 seconds. Go. You guys got your answers? Come on, guys. Come on, come on. No answers for this question? Okay, like, do you guys know what question I'm talking about? No, it's pretty. You could do it without that much time, I feel like. It's pretty easy, no? Oh, I guess like putting in the variables takes like practice. That's fine. DM is fine. Yeah, I would prefer DM. Oh, I just got a Michelle. Sorry. Okay. I'm just gonna like if you want to do this really quickly, if you want to do this like quickly, you just have to realize that it's rest, so that immediately means that there's no velocity in the beginning. So this is equal to zero, and and then no, DM means direct message. Um, sorry, back to what I was saying. This is equal to zero because it starts at rest, and then you should recognize that A is equal to 2, and then T is equal to 5, so you do 2 times 5, which is equal to 10 really quickly, right? It takes practice, but you guys will get faster and faster at it. Um, what do we have next? Oh yeah, this is the other displacement equation. It's just v I so sorry v sub I t plus 1/2 at squared. This should be v. Don't worry about u. Something that a lot of physicists use is they just use u as equal to v sub I, right? It's just the initial velocity, and instead of saying initial velocity like v sub I, they just use u as initial. So if you ever see u like this, that's just equal to um, v sub I. Go ahead and do the equation though. If you guys weren't here to create the kinematic equations as well, don't worry about it. Just like trust that these equations work and memorize them, right? You guys got your answers? It's a confusing. I'll go through it. Just use the equation given below. You just have to substitute numbers in and solve. 1 more minute, 55. I'll give you guys until 55. Zero answers. Oh, there we go. Yeah. Oh, we got, sorry, I wasn't looking at chat. What the heck? There's so many. Never mind. Okay, I'm getting a few responses or like different responses. I don't know if it's because wait, I don't think I think it's just computing errors. Because so if you guys think you just go through the math again, but I'll do it with you guys this time. Um so we know 5 goes in for V. Okay, let's label all our variables actually. That makes it a lot neater. You get V sub I equals 5, T equals 4, A equals 2. Correct. We have all our things. Now I can just put it in. So we just get T squared, which is 16. 16 times 2 times 1/2. These cancel out. So 16 plus 20, 36 meters. For the people who didn't put their units, please put your units next time. It's very saddening to see no units. For the people who got a different answer, like, could you like explain to me like why you think you got a different answer, or like because I can walk through it then, or is it just because of a computing error that you guys got a different answer, or if I got a different answer? I don't think I did it wrong though. No, I don't. Yeah, is it? Did people mainly just make a computing error? Okay, I'll explain again. So we have our three variables to solve the distance, right? Um, 5, 4, and 2, right? The initial velocity is, I like what Lucas does, right? I think Lucas taught you guys to underline. So let's underline initial velocity, A, and T4, right? So when we input 5 for this, we get 5. When we input 4 for T, you just get times 4, right? Which is 20. And then you have 1/2 AT squared. You input 2 for A, 1/2 times 2 is just equal to 1. So you just get 1 times t squared. T is equal to 4. 4 squared is 16. 16 times 1 is equal to 16. So then you get 16, and then you have to add 16 back to 20 to get 36. Does that make sense? Just computing error. Does that make sense, Sanchana? Oh, okay, okay. Okay, so but you guys get it though. That's the thing, right? You guys aren't like confused on how. Okay, that's good. It's just computing errors then. That's okay. That'll get done with time. Okay. Oh, next one. Third kinematic equation. You guys remember this one? Do you guys remember all these? I hope you guys remember these. These look familiar to you. They're not like wide-eyed. I remember, yeah, we'll do look it in a bit. I remember the first time you guys saw these, you guys are so lost. Um, but hopefully it's more memorable now. Oh yeah, this is equal to, sorry. I should probably do it was this is equal to change. And so just change in distance. A car accelerates from initial velocity of to 10 meters per second to 30 meters per second under uniform acceleration of 5 meters per second squared. What is the distance? Oh, it's looking for distance? Okay. I guess it's looking for the distance. You're supposed to solve for x in this case. That's a bit trickier. This is a bit trickier to do. You guys can go ahead and solve. I'll give you guys until 3:02. 3:02. Make sure you guys label your variables, all the variables that you think you're given in this problem, and then plug it in. If you if you label all your variables to plug, I'll do that for you guys right now since I'm so nice. You're supposed to solve for x. You're supposed to solve for the distance. It's already technically it's given you two. It just hasn't labeled it as clearly as you guys think. And then there we go. Right. There's three variables within those things that I underlined. I'm getting different answers. Anyone else solved it yet? Please DM me if you solved it. I've only gotten two responses so far. That's sad. Sorry, I was on mute. I think a lot of you guys are making really simple mathematical errors. Um, if I type in chat, like if I type this symbol in chat, it just means to the power of, right? So if I do 10, this, 2, it's just 10 squared. So I'm just gonna go ahead and do it with you guys, right? So we know the final velocity is equal to 30, the initial is equal to 10, A is equal to 5, correct? We're given those three. I think everyone got those down, which is great, right? But now we have to do is you have to input it correctly. So you get 30 squared equals 10 squared plus 10x, correct? Because 2 times 5 is just equal to 10. I just did it really fast here, right? So then when you get 900 equals 100 plus 10x, right? So then you get 800 equals 10x. So then you get 80 equals x because you divide each side by 10. Um, like, oh, oh, I didn't see that. Sorry, Sinchana. That's on me. Sorry, Sinchana. That's on me. You would have gotten the right answer then. But I think yeah, it's good. You guys are doing well. It's just like simple math errors. But other than that, you guys are getting how to like use it in the right context, right? So yeah. Ooh. Let's just do wait, I want to do all these. Do you want to do any of these? Actually, yeah. This way you have to like choose the right equation. Do the last one. This is the one you have to do. I'll give you guys until this is the one that needs to be done. I'll give you guys until three 3:10. Three yeah, 3:10. I've only gotten one answer so far. Sorry, I'm doing it in my head right now. I should verify. 100. You guys can use calculator if you guys need. Also, if you guys are sending me an answer, could I also like get the equation you're using, like the format you're using to solve for that? It helped me a lot last time to um see where people are getting stuck. So for anyone who's just a DM me an answer, could you also give me the equation you used? I like the units though. People are giving units. I'm gonna message everyone. So you guys are given VI, A, and X, right? And you are trying to solve for VF. Ooh, I forgot I have an iPad. Never mind, guys. Sorry. That's um does anyone have an idea though? If we're given VI equals 20, A equals 2, and X equals 100, what equation we could use that has all three of those, and then we're trying to solve for VF. Do you guys have any idea which one has all four of these variables? Could I get a message in chat? Close, close-ish, yeah. But I got it's wait, actually that's it's actually VI or sorry, V, yeah. You can just say X. You don't have to say change in X because X is just equal to displacement. It's not that deep, but VF squared equals VI squared plus 2AX, right? This is an equation we can use because there's all four of them. We have the F that we're looking for. We have the VI, we have the, not the 2, sorry. We have the A and we have the X. We have all the ones that we're looking for, correct? Oh, sorry. Correct? So we can use this equation. Does that make sense to you guys? Once we have all the things, now we can just input. I think the hardest part is like figuring out what equation to use when. And like, yeah. So since we don't know VF, we can just leave VF squared as is, but we have VI, which is 20, right? So 20 squared plus 2 times 2 times 100. Does that make sense so far, what I did there? Yes. Okay. Once we do that, what we end up having is 400 plus 400, correct? Which is 800. 800. And 800 is equal to, so 800 is equal to VF squared, correct? So when 800 is equal to VF squared, either we can put this in like decimal form or we can put it as like, do you guys know like square root 800 is just equal to 20 square root 2? Do you guys know that? Because 400 times 2 in per square root form is just square root of 400 is equal to 20, and the square root of 2 is 2. So it's, but if you guys don't know that, don't worry. Just put in the calculator. Just do square root of 800 and you'll get 28.28 equals, sorry, VF is equal to 28.28, something along the lines of that. Yeah. Does that make sense to you guys how I got that number? Or, yeah. Because it helped me a lot when you guys told me like what equations you used. Because once you tell me what equations you used, I can figure out how you got the wrong answer. Because if you gave me the right equation and you had all the numbers in place, that means it's just a computation error that you made, right? Error that you made. But if you gave me the wrong equation, that just means you chose the wrong equation, right? And choosing the wrong equation is not that big of a deal because you can always switch, it's not the end of the world. But what? Let's go to, okay, we're not even through rotational kinematics. Okay. Let's see how far. Okay, I guess this is what we've been doing every single class. I'll give you a quick introduction of what rotational kinematics is, and then once I give that quick introduction, we can do a book it. I just realized that's what we've been doing every single class. It's just been a review of what we did last class and then an introduction of a new topic, and then we review that new topic next class. So I guess we're just gonna do. Ooh, oh yeah, we're gonna cover all this as well. So relative motion's just like based on like two things, right? If I'm going in a, I think I've used this example. Ooh, this is a beautiful car. Oh my God. If I'm in this car and if I'm going 5 meters per second, right? But let's say I'm racing Bob, and Bob is much faster than me. Bob is going 10 meters per second. That is that is relative to someone standing on the outside. Looks like a Cybertruck to me. It might be. That's relative to someone outside, correct? But let's say I want to know how fast Bob is going relative to my car, right? Relative to my car, he's only going 5 meters per second because I'm going 5 meters per second and he's going 10. So we just do 10 minus 5. So he's going 5 meters per second relative to me. I see him only going 5 meters per second. Does that make sense to you guys? It's like pretty simple math that I kind of made a little more complicated because it's like relative motion. So everything is in relation to some point, right? When we're saying a car is going 30 miles per hour, that's 30 miles per hour in relation to the ground that it's going off of, right? But if I'm in a car and I'm saying that car is going 30 miles per hour, that means that car is going 30 miles per hour faster than I am going to, or faster than I am, right? So if I'm going 10 miles per hour, yeah, yeah. But it kind of does become like harder once you get more deep into physics because like it matters what reference frame of like what frame you use a lot sometimes. So yeah. Yeah, that's what I was just talking about. Frame of reference, guys. That's like it depends on like which how you view it. I'm not gonna cover that here. But this is what we also just did. 10 minus, that's what I did, right? You can take a picture of the slide. It's actually a good slide. I'm proud of this slide. Take a picture of the slide. I don't want to explain it again, but it's pretty simple. Right. Yeah. Lucas also helps make them. Lucas does some of the slides, but I've made a lot of these slides. Mhm. That's concerning. Thanks. Thanks a lot. Okay. Uh, okay, projectile motion. Oh, this is another fun one. Wait, I don't know. We might have to go over and do a look at again. We might have to like go until 35. Is that fine with you guys? If we go until 35 to do the block? Because I want to cover, I just want to introduce it. I just want to introduce what do you call it? Rotational kinematics, and we can work with it next Sunday. But projectile motion's like just the it's like the we talked about projectile motion, right? It's just like if Bob throws a football like in this is projectile motion because he's throwing it in a curve, gravity, and then there's the X component, comp, and then there's the Y component, Y comp, right? There's two components to this. There's the one that goes up and down, and there's the one that goes side to side. Oh, wow. Look at that slide. I just covered it. Horizontal and vertical, correct? Ooh, look at this. You guys can take a picture of this one. I'm also proud of this slide. Um, uh, go ahead, take a picture because there's a lot of variables here, a lot of things that it'll be good to know. Good. Can I move on? I mean, a lot of this you already know. Like you already know like what you like I would say you guys know this. Because range is just horizontal distance covered. Height is just this way. You guys also know this then. Hey, you guys know everything, right? No, I'm joking. You guys know a lot of it, but there's obviously 4 or 5 variables that you probably don't know out of this slide. Um, but yeah. Okay, yeah. This is so remember we talked about remember our two equations we had? V sorry. So whenever I say y, I'm talking about vertical. And whenever I'm talking about x, I'm talking about horizontal. So Vy is equal to the initial y component minus gt. And if you notice, this is like another equation we've seen, right? Correct. Wow, so similar. It's negative g again because g is downwards and it's um like that. And then everything else is the same basically. You just substitute it out for g because acceleration g is an acceleration in a horizontal or sorry, vertical, right? And then you do the same thing with this, right? The distance vertically is equal to Vyt minus 1/2 gt squared. Again, it's minus g because if you, it's awfully similar to this equation, right? They look awfully similar. I'm not very proud of this slide actually because the format I made this slide in is pretty bad. I'll take full blame, but this is not very readable. But actually no, some of it is. I'm semi proud of this slide. Let's just say that. Um, but like you see how we just substituted vertical. Um, yeah, I made it. Lucas helps a lot with the formatting. So whenever you see something neatly written, it's because of Lucas. So you can applaud him on that. But it's just the same thing but vertical, right? It's just G instead of it's just minus G, It's all like this things we've seen before, right? So when you look at the other variables, it's just like translated almost. It's very common in physics, actually. Oh, remind me to do this next time. We don't have time for that. We'll also do this, but let's go to rotational motion. So rotational motion is basically when an object spins or rotates around an axis. I think you'll see that. There's three, yeah, there's three variables that are used, right? Instead of when we're using normal, you see these three, right? But when you're using rotational, it's just this is called theta, this is called omega, and this is called alpha. Yeah, I'm pretty sure. I'm pretty sure I hit all those. I don't know my Greek letters like that, but they're right on most of that. But when you look at the next slides, it looks like these symbols look a lot more complicated than these ones, but it's just like it's basically like um the same thing. Like if you look at angular displacement, it's just displacement from like how much this area covered, correct? So if it started with this much and it moved to this much, the displacement of the angle is this much, correct? This and this is the angle, but it's the same thing. Remember, we just got delta x is just equal to xf minus xi. It's the same thing, but I'm just replacing the variable, which makes it angular, right? Same thing with the next slide. It's just this looks a lot more complicated than it is, I promise. W is equal to, sorry, omega is equal to theta, change of theta over change in the time. Remember, it's just V equals X over T. Same thing here. Theta is equal to X, T is just T, and W is equal to V, right? Same thing with acceleration. Acceleration is just, or alpha is just equal to change of W over change in time. But that's just double, remember, omega is just equal to V, T is equal to T, and alpha is equal to A. But this is all just talking about when you're going in a circle, right? So when you're rotating around an axis, it's just talking like if you're looking at a car wheel, this is all rotational, right? It's not moving this way or that way, but it's moving around its axis, which gives it rotational. So, yeah, we'll talk about it more next time, I think. Yeah, look, this is what I was wanted to show, right? If you just look, it's almost everything is the same. It's just remember, see that once you see that, you can see that all of these are basically just it's the rotational kinematics is just linear kinematics, but just substituted variables talking about tires rotating or anything else that's rotating around an axis, right? Does that make sense to you guys? Yeah. Okay, I'll just pull up a quick look at about rotational kinematics and projectile motion up quickly. Look at Oh, yeah. Sorry, guys. Oh, you have to go now. Okay. For people who can stay, we'll just play a 5 minute book it with everyone. Bye. Oh my God. Sorry, guys. Oh, okay. Okay, this is a bit. Oh, okay. I would be surprised if you guys actually no, this is too hard. Too hard. Okay. This host game. What do you guys want to do? Which I would recommend you guys do it. Do it for like 4 minutes. Like just 4 minutes and then you guys can leave.